questions is livestock lineup, which is actually we cover in our sessions, which is a typical sorting problem. But in general for sorting, you have to be very solid in terms of sorting existing, objects of existing class, such as sorting for integer numbers, I mean, sorting for strings, and sorting for anything like a characters, which you should be know how to implement the comparable or comparator interface. The second is whoops, did I stop sharing? Let me share again. The second is when you have your own class, you define your own class, and then how to sort the objects of your own class based on any attribute. So this is still coming back as to how you define how to compare. The way reflecting how you implement the comparable, how would you implement the comparator. So that would be a very down level coding stuff. But for questions, in terms of solving approaches, a lot of questions you have to sort it out before you can apply the algorithm, such as greedy algorithm. So typical greedy algorithm, that is you have to sort it out before you can apply the transversal, so you can put whatever logic you want to put in there and resolve the problem. And in terms of sorting, there's recursive sorting, there's iterative sorting. Now, our recommendation is in your test, if this is typical of one step that needs sorting, go ahead using API, because that is recursive sorting, which is a log n, going to be the time complexity, which is much better than O of n squared for your own iterative sorting. But for today, those are kind of very like a wash and bottle level, which is not going to be interesting for today. Today, I want to talk about one more sorting, which is called bucket sorting. I believe in our sessions, we have such a discussion for bucket sort. What is a bucket sort? Bucket sort is you want to treat up the space for the time. So you gotta maintain a data structure, well, aka a bucket. And then for whatever intermediate result, you just put into the bucket. Instead, you put into a array list. The nice part about bucket sorting is that it will improve the overall the time because literally you put that data into specific labeled bucket. And then later on, when you want to revisit, you know which index to go to. That's a constant time for search any results from the sorting. So that's a very important part behind the bucket sorting. And I do believe for both bronze and silver, we have the typical questions practicing that point already. So for today, we want to deep dive into the second question back and forth. So look at this question. I assume everybody already read it. I don't want to spend time read it again. This is a typical question that take in two parts. The first part is you have to translate into a several cases. Now this question said is you have two barns, right? Each barn have 10 size of buckets or 10 buckets with different size, you do not know. Now, if you look at this example, again, I will not repeat the question. So that's why important people using your time wisely. So do understand the question ahead of session because I will not read through because it burns time. You see this example. This is barn A, this is barn B. Now barn A has 10 buckets. Well, the size has been, put in down there and the same as the barn B. The logic here based on question context that is, on day Tuesday, on Monday, it's a 1,000 gallons for barn A and barn B, which is starting point. And starting the Tuesday all the way for the following 4 days, what's going to happen is FJ Parmesan going to take a bucket from the barn A and grab that, corresponding number gallon of milk and put into the barn B, and it leaves the bucket in the barn B. For example, it takes the size 2 bucket and get to the barn B, so you're gonna leave the 2 there. And then on the that's what happened on Tuesday. On Wednesday, well, farmer drive gonna pick anyone among the 11 buckets and grab the milk and put into the barn A. For example, you get the 5 and move into here. That's a Wednesday and Thursday. It's kind of repeat the Tuesday, isn't it? You grab any one of the remaining 10 buckets in the barn A and pour into the barn B and then leave the bucket there, whichever that is. And on the last day, Friday, well, it's repeating like a Wednesday and coming back. So this is a typical, you can treat it as a simulation problem. In terms of simulation, we have different levels. Like the first topic, the first week, we're talking about the simulation literally. That is a follow the procedure without associating any data structure or algorithm as necessary because it's so simple. Or a typical simulation problem, you have to associate with, advanced data structure, for example, priority queue, to help you define the next step in order to finish the simulation. Now, for this problem, what would you do in terms of brute force? Well, the fairly just associated to the first type of simulation, well, just go ahead and simulate the process. So you're going to have a 4-4-4-4 for loop to simulate. You have to pick a 1 out of either 10 or 11, depends on which barn you're coming from. And, after that, checking the balance, checking the amount of milk in barn A and barn B and get it down. It's not a big deal for this problem. Actually, you may pass the USACO by doing that because for each for loop, what is the time? Either 10 or 11, right? Let's just say 10. So this algorithm will be 10 to the power 4, isn't it? 10 to the power 4, well, look at this. We are not have a lot of overhead behind each data. This is just an integer. I would say 10 to the power 4. Well, how likely you can pass all the use cases? And in these questions, you do not have any extending for the use cases. This is just saying, just 10 integers. With that being said, this question is a typical easy level question, but I want to use this question just want to bring, remind people regarding the bucket sort or bucket holding. And this is a very typical one to practicing now. All right. Now, since everybody understand the question, let's go to the coding pad here. So for this question, let me get to what is method 1? Method 1 is a fairly brute force, right? What gonna be the first for any possible for Tuesday, and then for any possible for Wednesday, of course. And here you're gonna update the amount of milk, let's say for barn A, right? Because any possible bucket, pick from A to B, right? For Tuesday. And then for the second for loop is any possible bucket, any remaining possible bucket from B to A for Wednesday, so on and so forth, right? It's really not a very challenging problem, but it would be very interesting for you guys to code it out. How is going to maintain the available size of bucket so you can pick for the next for loop? That's the only area you should be worried about for the first method. So pretty much the first method for this brute force for simulation. So what's gonna be the time? Time is gonna be 10 to the power 4, isn't it? That's it, right? 4, 4, 4, 4. And after that, just checking whatever possible, milk out there, and you're gonna return the answer. So that would be the method 1. Let's talk about the other methods. So this method is actually, we want to practicing instead of just simulate. let's try to shift this problem in terms of case discussion. Now, what I mean by that is you have you got to think about this, that after 4 days of swapping buckets, basically like that, right? So you have, let me copy the example, user cases down to here. So the second method, we can shift the problem in terms of that is, we can think about, this problem is a literally swap the bucket. For example, this question simply asks, you know what, this game is just like, after Wednesday, Tuesday, just one bucket from A to B, and Wednesday is coming back. Now, this problem is what? This problem is going to be like, one of the cases is just swap the bucket, and it's swap the bucket and checking the delta. So if you can have how many different delta of bucket size, they're going to define how many answers for this question, right? So now, with that in mind, now look at the full footprint of this question. This one takes about 2 rounds of swap. Tuesday, A to B. There's a bucket to B, and Wednesday, a bucket from B to A. So 2 days you finish kind of one swap. But for the one swap, there will be situation that is, one bucket from A now is in B, and one bucket in B now is in A. The second situation is you literally grab the same bucket where you move from A to B, and then you move in that, going back. That doesn't change anything. Then the delta is going to be 0, right? So with that being said, now you're going to have several situations. Situation 1, that is in the barn A and the barn B. The first situation, what I'm talking about is after Friday. If you look at the bucket, and there got to be some bucket what belong to the barn B now, in barn A, and some belong to barn A initially now is in the barn B. We cares about the delta of the bucket size. They're going to define our answers, So the first situation B, situation 1, that is after 2 days, I have 2 buckets initially in barn B, now in barn A. Is possible, right? For example, 1 and 5 swap, and 2 and this 5 swap. So in the barn B, instead you have AI and AJ. So B stands for the bucket words belong to B, A stands for the bucket words belong to A, and the index just represent a bucket. That's the first situation, isn't it? What about situation 2? Situation 2 is, like Tuesday, Wednesday, I swap 1 to barn B, and then I swap 1 back. Possible, right? So you swap 1 to 5 and swap back. So situation 2, that is after 4 days of swap, you just have BK and AI. You only have 1 bucket from the opposite barn. That's the second situation. What about the situation 3? Situation 3, that is no change. No change. Well, you know what? The Parmesan just don't bother. 1, 5, swap back. Then Thursday, 1, 5, swap and swap back. So nothing changed, isn't it? These 3 cases, which are mutually, exclusive. So you can go ahead with this discussion. So in terms of solving approaches, you can definitely shift the problem. Either you can go ahead with simulation. If you can see the time is you can handle, why not? If not, you could define into or divide into different cases for discussion. Okay, next one is to how to find the delta of the bucket size for situation 1, 2, 3. For this one, what we want to know is the AI plus AJ minus BK plus BJ, right? how many different delta that defines how many different results. And for the situation 2, what you want to have is AI minus BK. For the situation 3, just 0. All right. Okay. Now, let's just think about situation 2. That's a kind of fairly simple scenario. And only one bucket swap to the opposite barn. So how to handle situation 2? That's a fairly easy, right? That's a for loop. For and for. The first for is for any bucket in A, and then for any bucket in B. So basically, going to set out the pair, and then swap, and then what? And then count A minus B. Right? So then they're going to open up another question. How, well, we want to have a unique count or a unique delta. So what data structure going to help you on that? So now I'm still talking about, I'm trying to limit this topic as to bronze level. I mean, for server people, definitely hard set, right? Harsh amount. But let's say for bronze, like a very basic bronze levels, you haven't learned the set or map that interface data structure yet. So for this one is a perfect scenario or use cases by using bucket sort. So for this bucket sort is that you're trying to figure out the maximum possible delta. What is the maximum possible delta? Because the size of the bucket is from 1 to 100, isn't it? Let's just think about the worst scenario. That is, every time you grab stuff from A to B, you grab the small one. And you swap with 1,000, I'm sorry, 100. So you got the delta to 99. And when you swap B to A, you always grab the 1 in barn B and swap the 99 in A. Sorry, 100 in A. So always the delta, I'm talking the worst case, is the 99, right? So with that being said, so the maximum, the possible delta range, gonna equals what, folks? Minus 99 times 4 to 99 times 4, all right? So what is the 99 times 4, which is 400 minus 4, 396. How many numbers? 396 times by 2 divided by 2, sorry, plus by 1. You only need 793. You only can have a 793 possible delta at the end, right? That's a maximum. So given that, you see the distribution of the potential result is such like nothing, 793. Go ahead to create the bucket to literally have a bucket for each possible delta. So that's a nice part behind the bucket sort, because you never worry about how the data, end up in whatever data structure, and later on when you're trying to revisit it, you don't have to traverse it anymore, because the index stands for the answer, or stands for, it can associate to the answer, which is all of one time, you can get it. So that's a bucket sort. Clearly the trade-off is about the space. But like I said, if you see the distribution of the potential results is such tight, why not? So with that, pretty much you want to creating a, you can create a Boolean called a total difference. And this one, you're going to have how many, what is size you want to put in there? 793. Right? So this is coming from where? 396 plus 396 plus 1. And what is this one? This one stands for the 0, for the delta. But the challenging thing is, you could have the delta could be minimum, right? I'm sorry, could be negative and could be positive. However, for our total diff, for this Boolean, the physical meaning stands for that for the index I, if it is true, which means that I stands for a delta that exists from the simulation. However, how can you represent the negative answers? So a further easy way is whatever delta you can have, just add a 396. So originally your delta range is a minus 396 to 396. Now, for whatever reason, just add the constant 396, then you're gonna have a range. It's coming to where? 0 to what? 792. Isn't perfect for your 1D array with the size 793. That index stands for the so-called the delta, right? Just add a 396. So this bucket definitely for this example, I would say is just nice to have. But let's say I have a follow-up for this question, that is after you figure out how many different potential delta, the follow-up could be easily asking you, hey, tell me what is the minimum, what is the maximum, whatever middle numbers I'm interested with. Could you find me that? Now this bucket or this bucket sort really can help you in that regard. But still again, for this, they can help you for deduplication because you never cares about the same delta, you cares about different delta. And the second one is you're going to record it as accordingly, correct? So we are taking situation 2, you're going to use a for loop, and also you're going to have a maintain a total diff, a Boolean 1D array. So true stands for exist, and definitely at the end you just traverse the total diff and checking how many true. They're going to be the answers. For situation 3 is also no problem, right? So situation 3. So situation 3 stands for that total diff at what? 396 equals 0. Why? Delta was 0, right? You should add 396. So that's what total diff 396 equals 0 to record that data. Now, really just a little, not that much is about the situation 1. For the situation 1, that should be coming from the sum of 2 buckets from a bond and then find a difference. This is just a one layer of washing butter, isn't it? So in order to continue, you just need to translate situation 1 into situation 2 in terms of you're trying to create it with this 1D array, trying to create another array that is record any possible sum of the 2 numbers. That's all about, right? And while you do that, you still have to do the duplication, because not necessarily you want to looking at the sum of BK plus BI and doing that with AR plus AJ, which is unnecessary. So going to situation 1, you have to find unique sum of 2 buckets from each barn. Right? And after that is what? And it's similar to situation 2, to find unique delta. All right. I think up to this level, I think it's clear enough for second method. And if you look at the second method, do you see we have any time complex beyond 10 square? No, right? For situation 2, this is a for loop. All right. For situation 3, that's O of 1. For situation 1, well, the first step, find the unique sum. That's a for loop. That's n square. Also like a pre-processing. And then you move on to situation 2. Now you tell me what is the time? 10 square. Though this not, I don't see making much difference in terms of can pass or not pass use cases, because literally this is still on very low level. But easily this question can expand the use cases, and then you should be solid with the second method by using bucket sort and using bucket to hold the answers. right? Of course, for silver people, you can also use Horstat. It's also working. Okay, so with that, I want to quickly code it out. Uh, but important thing is you guys need to be solid. I don't really care about the coding that part, but I'm curious about people, how you're gonna start with the brute force and how you identify the areas so you can optimize it. That is a very important part. I mean, you can see that picking up for bronze, but very heavily checking for silver. So that's why all those questions I would say, perfect for both bronze and silver in terms of you uh, reviewing the relevant topics. Okay, so let's go to so these questions. What is the class name? Back and forth, right? Uh, okay, so go ahead with that. Let's copy the template here. Read and upload the file here. Uh, and get her here. All right, let's get started. Clearly, what is the first step? To record the two array of buckets from each barn, right? This is just go ahead with into barn A, new int, this is 10, and for loop. See, that's Java. You have typing a lot of stuff. Where it's more user friendly for C++, but that's not a focus. For the algorithm and also the data structure implementation, that makes no difference. Okay, so that's you're gonna record what happened for the barn A, and then go ahead with the barn B, just copy and put down here. So just go to barn B, then the barn B, right? All right, so now you record what the 10 bucket within both, and then you can close in the file. And then move down to here. Let's talk about the situations. Which situation we want to discuss first? Remember what those situations? Let me try to copy those situations so people don't lose the ground. Situation one, we're gonna have 2 buckets from opposite barn. And for situation 2, just 1 barn. All right. And for situation 3, that's no change. So that's the 3 situations and also 3 cases we're gonna discuss now. All right. So before we discuss any one of cases, remember we had to maintain a bucket where it's called total diff. And the physical meaning I already explained. The index stands for the corresponding delta exists from the answers. So what is the size? The size depends on what is the max, right? The int max possible maximum range is 396. That's coming from 99 times 4, right? So this is a new boolean. The size y is going to be max times 2 plus 1. All right. Of course, that's going to be 793. Okay. So that's that. And let's talk about the situation 3. Why not? So case 3, situation 3. Situation 3 is what? Fairly easy, right? What is situation 3? Situation 3 is called a total diff and 0. What does 0 stand for, folks? 0 stands for the absolute delta from the 2 barns. But in terms of for that 0 to be logged in the total diff, you need to add 5 max, correct? So this is by, the index 396, that is true. So far, people follow? Okay. And then let's move on to situation. Which situation you want to discuss? Situation 2, right? Let's talk about easy one. Situation 2. Situation 2, this is a for loop, right? It just, watch the bottom, I equals 0 and I less than 10, which is you traverse every possible bucket from the first barn and go ahead and traverse any possible bucket from the barn B, right? And then what? And then just record. And then total diff, so here is what? Barn B at the J minus barn A at the I, and then plus max and record it. So you could have a repeat, but doesn't matter. It's still going to be recorded as a true. And then later on you traverse and figure out how many truths and you get it down. So that's the second situation. Let's move on to the first situation. This one, take a little study. So for this one, guys, you have to figure out how many unique sums from a pair of two numbers in a 1D array. This is just go ahead and use brute force, make no challenge. And for this one, you can go ahead by using such a bucket sorting method or bucket to record it. So you can use a boolean called sum a new boolean, and the size is 200. Why 200? The largest sum equals what? Equals a 99 plus 100, right? 199. So the maximum is a 199. That's why you declare 200. So it covers from 0 to 199. And boolean sum base and 200, same reason. Okay. And next one is just go ahead and record it, the sum. Come on. Into I equals 0, less than 9, and I plus plus. So why we stop at 9? Because we want to have the second number within the boundary, I plus by 1, and J less than 9, and J plus plus. Right? And what's inside? So you're going to have a sum. You're going to have a barn A, right? I plus barn A, J, right? Equals to 2. And copy this line. And you're going to have this one. So this is going to be barn B and barn B, right? That's it, right? So after that, basically you're using this bucket to record how many unique sums, and then just get it out. From that, you could create a list because you don't know how many, right? Custom barn A array list. So the physical meaning of this array list is to record the unique sum from barn A out of 2 buckets. And the same thing for the second one. You can the sum barn B, and with that, that's another levels of washing the bottle. So 4 int I equals 0 equals 0, I less than 200, and then I plus plus, and go ahead and record it. Right. So if sum A at index I exists, well, guess what? Sum barn A at what? At I. Right? Copy and do the same for barn B. If sum B exists at this index, so the sum barn B, just add that, right? Sum barn A, sum barn B, making sure we don't have a typo here. All right. So with that, next one is repeat the same stuff you get from the situation 2, right? Now, what's next? Is another for loop, right? So for I start from 0, definitely, and I less than sum barn A size, and I plus plus. And then for inner is int J from 0 j left, the sum barn b size and j plus plus. Okay, so now the total diff, now kicking here one more time again. So gonna be what? Sum barn b get, because it's an array, list minus, come on. So sum barn a get I. Don't forget plus max, just record as true. Now, up to this point, so we finished discussion for situation one, which make no difference. You just have to figure out the sum and also unique sum. If you don't care on that level, it's also fine because you have the duplication in your total diff. So after that, and then just wrap it up. Result stands for the unique. So have a for each loop, asking whether or not that exists from the total diff. And if yes, and just add a 1 plus plus. There you go, and then print it out, right? So that will be the code. Let's review that, and then we can commit it. Now, so this question overall, we deliver 10 squared on the complexity, which is much better than the brute force simulation. First of all, you're going to record the size of 10 buckets from barn A, right? That's what we do, and barn B as accordingly. And then we're going to have 3 situations to discuss, and we have a total diff to record, the space to record whether or not that diff exists and a unique diff exists. So, but in order to using a space starting from index 0, you had to add 396. So that's what the part you're going to be very careful with. So that's why we have a max constant there. And also the total is going to be 396 plus 1. 396 times 2 plus 1, 793. So starting with the situation 3, which is 0 plus max, which is 396, at that spot is true. And the situation 2, this is a for loop. For I, for j stands for the possible buckets from each barn, and checking the difference. The barn bj minus barn ai, and don't forget plus max. So making sure no negative. And that's the situation 2. And the situation 1, first of all, you want to figure out the unique sum. And the possible sum. This is again the bucket method, right? Because the maximum sum is 199, and you got all integers. That's why 200 spots is good enough, right? So you got sum A, sum B stands for at that index stands for there's a sum equals that index I. And then go ahead and for I, for J, so I and J stands for 2 buckets in that 1D array. And checking barn AI plus barn AJ, just making true. And similarly for sum B, barn B, I plus the barn BJ, well, this can be true, right? Now you maintain everything in sum A and sum B. And now you want to get the number out, and then you're going to have a 2 array list, and some barn A and some barn B, and then traverse all 200 numbers, right? If that exists, where is it true as a return from your sum A or B Boolean array, now just add that in your sum barn A and sum barn B, correct? Is there any bug here? No, I think so, right? And after that, this is similar way we're dealing with the situation 2 and for I and for J, and just find the difference. Sum barn B get J minus sum barn A get I, and don't forget to add the max, and then just leave as true. And finally, just wash out, figure out all the possible deltas. And the delta defines unique output for this question. Any questions? All right, so let's say, do we need to do any debugging? So let's upload the code. If not, let's debug. Okay, so get down to back and forth. All right, seems like there's no surprise here. And you see that this question typically like I said, is easy level, but I want to use a question to remind people don't forget about the blocky sort and when to use it now. As you can see, there's no cases extending or escalating very big. So that you see the distribution of the time is rather, consistent. It's like a flat line for the space and for the time. So that's that. Questions, why is a max 396 not 400 in situation 2 and 3? Let's go back. Question here, why the max? Where's my max? Okay, here. What do you think? Remember, what does the max stand for, first of all? The max stands for the maximum possible range. You have the bucket size from where to where? Your bucket size is from 1 to 100, right? Then the maximum is gonna be 99. So the 99 is gonna be the maximum delta you can get from one round. Now you have 4 rounds times by 4. That's why uh, you can have that. So I'm gonna share the code. I will not have time to go through the algorithm. So I actually wanted people to take this session in terms of 2 flavor. One, you finish the questions. You define the problem. You ask me what is the question in Q&A. I like it. Or B, you at least read the question, understand the question about, uh, and then you follow the algorithm. You review the parts that possibly already have in the bronze and the basic server and all advanced server class, and then deliver that out. And then if you still have a questions, and go to coding pad and comments, so that can bring to my attention. So let's do that in such a manner because the time is really marginal for me in terms of lunch break. So anyway, for let's wrap up for today's session. Uh, Sorting. Uh, there are 3 different levels in your context. First level, like a wash in the bottle. You have to sort it out so you can go to the next step. And for that, I believe that everybody is already very solid. Call API. Period. Second, there is sorting questions, which is the questions revolving around with, like insertion sort, the bubble sort, selection sort. There's kind of question context working around that. For that question, you have to be very solid with those 3 sorting algorithms, which we'll cover in our sessions. And I also offered more, such as rainbow sort, for example, making sure the algorithm you can deliver the code. That's the second one. The third one, the third one is association with other algorithms, as I already discussed earlier, sorting with greedy algorithms, right? And the sorting in terms of other data structures, such as sorting this behind is comparing, associating with a priority queue, associated with a tree map, just for example. So not just for sorting as a target, but you need to understand behind it to making sure the number, the object, or whatever you define to be comparable. You only have to make them comparable so as you can define priority queue, so as you can sort it out, so you can do tree map. As to how to making the 2 comparable or define the rules, so you could implement interface as accordingly, such as comparable or comparator. So you define it as your own rules to making sure they are comparable so that you can continue the algorithm. And one more level is bucket sort. So this is a very unique area, which is in general, trading off the space for the time. That's the whole driver behind that. So that's why when you see the distribution of the potential results is very tight, which means you can't, sacrifice the consecutive space, which is normally very expensive for that regard. And you can see the benefit for this question is just for the duplication. But like I said, if we have follow-up asking for how to revisit any specific data and for the following logic, you really need a bucket sort to list out all the numbers there so you can visit in constant time. You can get in constant time. And this logic can also be fulfilled by harstat, if not linked harstat, linked harsh map, which is target for the advanced server. We just finished that for our advanced server. But for bronze people, definitely for bucket sort, that is should be one of your list to handle well. All right, folks. With that being said, if you already finished the question, making sure you pass all use cases. If you haven't, try to deliver the code and the question is coming out in your coding pad. All right, folks, that's another week. And I wish you guys enjoy the sessions. I'll see you guys next week. Alrighty, bye-bye.